for this problem, we're gonna apply everything what it learned so far, okay? So, okay, look at that. So the boat is moving this way, and there's wind. Then true course is not this way, but because of the wind, it is moving this way maybe, right? So we're gonna try to figure out the true course, okay? To do so, like we're gonna try to write your boat direction as a vector component form, and the wind direction as a vector component form as well, okay? So let me give the name for this vector, okay? Let's say this is a boat vector, which is B, okay? And we have to find X and Y component, this one, okay? And then what about this guy? Let's say W, which is stands for the wind. Okay, also we're gonna write this one as the X and Y component form, okay? So look at the problem. The angle between y-axis and the vector B is given, right? But like you can use this one, but like, for like, make it easier, we're gonna try to use the reference angle instead, okay? Which is from the like x-axis, okay? So like since that is 60, that is 30, and this will be 60 degree. Okay, so as we practiced this one before, and we can write the vector B as X and Y component form. The length of B times cosine, so let me write it like exact angle, okay, 60 degree, and vector B times Y component, which is sine 60, right? We know about cosine and sine value of 60, right? Which is 1/2 and square root 3 over 2, right? So like, length of B is given, which is, what is speed of like the boat? It is 40 miles per hour. Is that okay? So that is equal to 40 times 1/2 and 40 times square root 3 over 2, which is 20, 20 square root 3, okay? What about wind? So the reference angle, this case is the same, which is 45, okay? So that is, in the same way, since the speed of wind is given as 6 miles per hour, 6 times cosine 45, and 6 times sine 45, okay? But you know what? Wait a minute. If you write like this way, it is wrong. Okay, so look at, like, let me come back to the vector B. B is in the first quadrant, okay, which means like, pointing like this way. That means X component is positive and Y component is positive, okay? That's why this is definitely fine, okay? But what about wind? It is pointing down there, right? X component is still positive, that's fine, but Y component is negative. But keep that in mind. All the trigger function between 0 to 90 degrees is positive. So if you write like this way, you have to decide your sign by yourself, okay? X component is fine with positive, but Y component must be negative. That is the important part, okay? Don't forget this one, okay? So like we know cosine 45, which is square root 2 over 2, and sine value is same as well, okay? So that is equal to 6 times 2 over 2, comma, negative 6 times 2 over 2, which is equal to 3, 2, comma. Okay, so this is the way to write your given vector as the vector component form. Okay. Okay, now we have vector B and W in a component form. Then we're going to try to find the true course, okay? True course is the resultant force, okay? Calculation of resultant force is really easy. Just add up these two vectors, okay? Here we go. So, true course, which is vector B plus vector W, just like simple addition, okay? It is equal to 23, comma, no, I said we're gonna add up, no, plus X component, okay? Don't make a mistake like me, okay? And then Y component addition, 3 minus 3 square root, okay? That's it. This is the true course, okay? So in the problem, I ask you find the speed. But keep that in mind, speed and vectors are different, okay? Velocity is vector, but like, speed is the length of vector, okay? So the speed is the length of this true course vector, which can be calculated by square root of x component square plus y component square, okay? So we are not a computer, so you have to use the calculator for this, okay? There's no way to calculate this one by hand, okay? That's it, okay? So now let's talk about one more thing, okay? The angle from like angle notation, okay? So I believe you're gonna have like this problem on your web assignment, okay? So that's why like I would like to talk about this, okay? So basically whenever you want to talk about angle, and we're gonna start from North Pole or South Pole, okay? So that's why on your web assignment problem, it is noted by north and blank and east, or north blank and west, something like that, okay? So we're gonna try to find that angle, okay? So let me draw this true course vector in x and y components, okay? Look at that. Your x component is positive and also y component is positive, okay? So your true course is somewhere here, like this way, okay? Which is 20 plus 2 and 20 square root 3 minus 3 square root, okay? So, well, basically, like as I told you, like your answer must be north, okay? Since like it's pointing this way, north and east, right? Your answer must be north and angle east, right? Which means you have to find this angle, okay? So how can you find this one? And it is simple trigonometry, okay? So let's make it right triangle here, okay? Then for this angle theta, and this side is opposite, but keep that in mind, that is x component, okay? Okay, and what about this side? That is adjacent of this triangle, of this angle. So that is adjacent, but that is exactly y component, okay? Does it make sense? And do you know why I'm doing like this way? Because I'm going to use the like tangent function, okay? So here we go. Tangent theta is equal to opposite over adjacent, which is equal to opposite, as you talked about it, your opposite is x component, 20 plus 3 square root 2. And your adjacent is your y component for that case. Just look at the right triangle, okay? 30 minus 3 over 2, okay? As we did before, and this is tangent theta, then your answer is your tangent inverse of your this value, okay? So your angle theta is equal to tangent inverse or arctangent of 20 plus 3, 2, 23 minus 3 square root, okay? So as I told you, your answer must be given by north, the angle theta, which is found from here, and east, okay? This is the notation for this problem, okay?